This call is now being recorded.
Hello guys, welcome to Department of Mechanical Engineering, Sai Vidya Institute of Technology, Rajan Gunte, Bengaluru 64. Today we are going to discuss on a topic called electrical actuators for the subject mechatronics with the subject code 17ME753. Our prime focus in this topic will be electrical motor. A motor is an electromechanical device that converts electrical energy into mechanical energy. You can see the pictorial representation of an electrical motor. Types of electric motors, that is, the electric motors can be classified into DC motors, AC motors, and other types of motors. In DC motor, further it is been classified into shunt motor, separately excited motor, series motor, compound motor, permanent magnet DC motor, and brushless DC motor. In electrical motor, another classification is your AC motor. Under that, you are going to study about induction motor and synchronous motor. Other forms of motor or other types of motor are stepper motor and servo motor. DC motor, under the DC motor, shunt DC motor, that is, the stator and rotor windings will be in parallel. The connection of stator and rotor will be in parallel. Whereas in separately excited motor, the rotor and stator are connected from a different power supply. So each pair of rotor and stator are connected from a different power supply, which gives another degree of freedom for controlling the motor over the shunt. Series motor, the stator and rotor windings are connected in series. Thus, the torque is proportional to I square, that is the induced current. So it gives the highest torque per current ratio overall when compared to other DC motors. It is therefore used in starter motors of cars or elevator motors, etc. Next thing is your permanent magnet DC motor. The stator is permanent magnet, so the motor is smaller in size. Only disadvantage of it is used for low torque application only. Another form of DC motor is compounded motor. The stator is connected to the rotor through a compound of shunt and series windings. If the shunt and series windings add up together, the motor is called cumulative compounded. If they subtract from each other, then a differentially compounded motor is seen. So we can use for the various applications based on the requirements. So you can see the arrangement. So A shows the arrangement for shunt motor, that is the motor is in parallel with the field coil or a stator coil. In figure B, you can see the series arrangement of your DC motor where motor and field or stator coil is in series. In C, it is compounded, that is your stator coil is both in series and parallel when compared to the motor connections. What are the disadvantages of this DC motor? So brush wear. Since it is a contact type motor, there will be a carbon brushes. Okay. Since the connection to the rotor winding is made through these carbon brushes, wear occurs and it increases in low pressure environment drastically. So these DC motors cannot be used in medical applications like artificial hearts or any other such medical related equipments or devices. If we are going to consider for an aircraft, the brushes would need replacement after 1 hour of operation, which is quite undesirable. So replacement of any parts in an aerospace or aircraft particles or aircraft components is quite difficult. Sparks from the brushes may cause explosion if the environment contains explosive materials. Noise from the brushes may interfere with electronic devices which is present in the near vicinity. AC motor. In AC motor, the induction motor is given the name because the voltage is induced to the rotor, thus eliminating the need of brushes like in case of your DC motor. But for this to happen, the rotor must rotate at a lower speed than the magnetic field to allow for the existence of an induced voltage. Therefore, a new term is needed to describe in the induction motor, which is called as the slip. Synchronous motor, it is so called because the rotor tries to line up with the rotating magnetic field in the stator. It has the stator of an induction motor and the rotor of a DC motor. In synchronous motor, we have three-phase rotating field require three pairs of windings at 120-degree apart energized by the voltages that also have a 120-degree phase displacement. Another form of synchronous motors are specifically designed to maintain constant speed with the rotor synchronous to the rotating field. Synchronous motors require modifications such as squirrel cage winding, and it should be self-starting. Another form of AC motor is your reluctance motor, a synchronous induction motor as it is called. The rotor has a salient poles and a cage so that it starts like an induction motor and runs like a synchronous motor. It uses a soft magnet rotor that is magnetized by the application of current in the stator coil. The magnet is spun by three-phase AC motor with no rotor voltage. The gear teeth are designed to increase the magnetic flux driving the rotor while providing asymmetry that gives it a rotational acceleration. The permeability of the rotor provides a significant increase in inductive power. Therefore, full solution of Faraday's law with time and velocity dependence will be achieved. Other motors, while we discuss about reluctance motor, it is a synchronous induction motor. The rotors once again will be like a squirrel cage arrangement so that it starts like an induction motor and runs like a synchronous motor. Hysteresis motor, it produces a torque, can be very little or very small. Okay, you can refer Chapman, Tata McGraw-Hill publications, page number 669, which briefs you about hysteresis motor at large. Stepper motor, a special type of synchronous motor, rotates a number of degrees with each electric pulse, giving the precise control for any kind of electrical device. Brushless DC motor, a close cousin of a permanent magnet stepper motor with electronic controllers. Transistor H circuits will be used for electronic controller. Universal motor, if a series DC motor has laminated stator frame, it can run effectively from an AC supply as well as DC. This is the universal motor. Servo motor is a closed loop mechanism that incorporates positional feedback in order to control the rotational or linear speed and position. The motor is controlled with an electric signal, either analog or digital, which determines the amount of movement which represents the final command position of the shaft. So that's all about the electric motors or electrical actuators.